Hey guys, welcome back to Business Analytics. We are going to roll with this video making thing, and we're going to see if it goes well again. So hopefully it does. So as I mentioned in the previous announcement, we are going to just do a video lecture slash class exercise, and that should get you prepared for lab. So we're going to see how this goes again. We're going to do it slightly different this time, just kind of for variation's sake, and just see if you guys like it better or worse or the same. And so there's not going to be an in-class exercises print-off, but you will just follow along with the slides and then follow along with the jump as well. So rather than there being like 3 documents like there were last time, like slides, or I guess 3 entities, slides, jump, and in-class Word, Word doc. It's just going to be slides and jump. So if you would like to print something off and follow along, I suggest you just print off the slides, and then you can take your notes on the slides and do it that way. So it's going to have a slightly different feel to last time, so it's not going to be like a worksheet to worksheet kind of transition in the same way that it was last time. But I don't think you're going to lose any value. And I think it's going to make it a little bit easier on me. So we'll see. If you guys don't like it this way after the fact, then we'll look to go back to the other way. I just wanted to try something different. Okay. So let's get started. So this is probably, decision trees is probably my favorite topic to cover in this class. So this is only the second semester that I've taught this class, but this is like by far the coolest, just the coolest technique that we work on, okay? And I think the last one was pretty cool actually too. I think logistic regression is kind of like this thing where it's like you've just got this whole slew of variables and you just toss them into a pot, and then you mix that pot, and then what ends up popping out is a sort of regression equation and some rules that give you sort of this really cool prediction model, okay? And that's kind of cool, except that I think it sort of does feel like we sort of toss a bunch of variables into a pot and see what happens. This is different in that we get something that at the end of it looks really visually pleasing, for sure, and then also is just really, really easily understandable, okay? And you'll see what I mean as we get into it. So let's go ahead and get into it. So decision trees. And like I did last time, some of this is just going to be me reading slides, and I'll try to elaborate as necessary. But yeah, we'll go with this. A decision tree, classification tree, regression tree is a decision support tool that uses a tree-like graph or decisions and their possible consequences. Transparent and easy to interpret due to the logical rules that are created to split observations. And it's just one of the typical supervised classical methods. The resulting tree can be expressed by probability statements. Consider the following 2 independent variables, age and education. A statement may be, if age is less than 55 and education is greater than 12, I assume that's 12th grade, then Y is associated with a predefined group, okay? And then we just use this tree structure to follow a path-based decision, okay? All right, the advantages of the trees, as I already mentioned, they're easy to use and understand, produce rules that are easy to interpret and implement, kind of similar. Variable selection and reduction is automatic. Yeah, that's something that's really cool about this. Once you determine what the important variables that you want to use are for this distribution, the thing just runs itself. It's not like with the other distributions where we had to do a lot of, I guess, analyzing and a lot of determining what the best variable is. There's going to be a little bit of that because you're going to want to pick the best variables. So we're actually going to use kind of some of what we did from logistic regression, which was the last video that we did, the last lab that we did. We're going to use some of what we did from logistic regression to determine what variables to use when we run a decision tree. But the really cool thing about the decision tree is you literally press a button that says go, and then it just goes, and it automatically creates all of the splits in the tree for you. It automatically does the correct number of splits, so it's not oversplitting or undersplitting. And then you're always going to have probabilities associated with specific classes in each portion of the tree, which if that isn't clear what that means, that's fine. You'll see exactly what I mean when we actually look at one of these things, okay? What is it? Do not require the assumptions of statistical models, okay, and can work with extensive handling of missing data. Oh, interesting. Okay, cool. Trees and rules. The goal: to classify or predict an outcome based on a set of predictors. The output is a set of rules. This is similar to what we've done in that, like, it's prediction based, but yeah, the output in this, instead of it being an equation, it's a line of if-then statements. Okay. What else can I read that you guys want me to expound on? Nothing. I think this is good. Oh, and then there's the two methods of recursive partitioning and pruning. Okay, and so that's just splitting and pruning. And the splitting is creating more partitions, and the pruning is taking away partitions. Okay, that is what that is. So we're going to do an example from the same data set that we used with logistic regression as well. Okay, and if you remember, we used the universal bank data set. Okay, this was for our in-class exercise, and we had a set of independent variables, and everything got mixed in the cauldron, and it spit out a yes or no. Is somebody going to be a personal loan customer? Because remember, that was the way that the bank made most of their money, so it was always best if we could figure out who these people were that were the ones that were more than likely going to be able to obtain a personal loan, because we would want to market to those people. Okay, so we're going to look at this exact same example, but with another tool, which that other tool is decision tree analysis. Decision tree analysis, is that what we call it? Yeah, decision tree analysis, sure. Sorry guys, I had to pause the video, so I'm back now. It probably felt like a moment's notice to you, but I had to go take care of something. Okay, so yeah, where were we? We were at getting to the universal bank example. So the same example that we used for logistic regression, we're now going to use for decision tree. So we can actually use just both of these things. Okay, so we're not going to get into jump yet. We are going to get into it in this video, but this is just a look at some of the output. Okay, so what you'll see, and this is something that now the program does all on its own. Okay, so what it does is it takes the, I think it was 50, or I think it was, yeah, it was 5,000 pieces of data, and it automatically decides where the best place to partition them is in order to group them in the probability of success of whatever variable it is that we're looking to predict. Okay, so if you remember from the universal bank example, it was all about, are they going to be a personal loan customer, right? So we want to know what are specific aspects of the data that divide people into categories. So that's not for us to decide, that's for the model, that's for the decision tree analysis to decide. So when we run this thing, what it does is it just starts to split the data, and it splits the data in a tree that looks a lot like this. So you'll notice that the overall data, and hopefully you guys can see my cursor. This is the first time I'm using this sort of screen setup, so I imagine you can see it. But I'm looking at the box that says all rows. What that does is it has the count and the probability and something called rate, which I'm not actually sure what rate is. In some cases it just follows the probability. In some cases it doesn't. So I want you to ignore that. I've tried to remove it, but I've not been successful in removing it, so I'm just going to leave it there. But so you just want to worry about, or you just want to know what probability or prob stands for, which is obviously probability, and count, which is just literally, the count of the hard data. So where we see 480 there, next to yes, that's just the number of yeses in the total data of people that yes have a personal loan with that company or in that data set, and no is obviously the people that don't. So there's 4,520 no's, 480 yeses. Okay, so then what the software does automatically is it decides on like the first best determining factor in order to split people into groups. Okay, and it does this with a categorical variable, and it does it with a continuous variable. So, and the cool thing about the continuous variables is it actually goes and it finds where it should split it within that continuous variable. So the first thing we see, we take one step down into income, or we take one step down and it splits it off into two branches, okay, of the decision tree, and that is actually what they're called, branches. Okay, and in the left branch we see that it says income less than 99. Okay, and then in the other branch it says income greater than or equal to 99. Okay, so in the income less than 99, what it is saying is that for the data such that the income is less than 99,000, these are the specific probabilities and counts of people that fit these certain categories. So, income less than 99, 36 people had a personal loan with that income, okay? But more importantly, the probability is 0.0096, okay? So anybody with an income of less than 99,000 had less than a 1% chance to obtain a personal loan, and furthermore, somebody with an income of less than 99,000 had a 99% chance of not obtaining a personal loan, right? Makes sense. But then we see over here to the right, income greater than or equal to 99, we have very significantly different probabilities, right? So now, suddenly, when somebody has a greater than or equal to 99 salary or income, they have about a 35-36% chance of obtaining a personal loan, and then we have the counts associated with that. And then their rate of not getting a personal loan is about 64%. Cool. So it's very easy to understand, right? It's just basically saying it's deciding where is a good place to split this such that we can subgroup these where their probabilities are different, such that the groups look a lot different. Okay? So we do that. And so then what it does is it goes and then it splits the first branch again. Okay? Because because the probabilities are so drastic in the less than 99 area, that's such a good predictor that we don't need to split that anymore, right? And it's not even us that's making the decision, it's the computer program that makes the decision. Okay, so what it's doing is where there is variability, or where there is play, I guess you could call it. Sorry, my phone just dinged. It's going to partition things again. So how do we again subdivide these? So then you'll see under the income greater than equal to 99, it splits it into different education groups, and it even groups some of the education together. So then it looks at and says, okay, well, if they're a person who has an income greater than 99, greater than or equal to 99,000, we can subgroup them into somebody who has an undergraduate degree versus somebody who has an advanced or graduate degree. Okay, and then we see, we look at the undergrad and we see that the probability of obtaining a personal loan then is about 10%. And, of not 90%. And then we look at the advanced degrees and we see, geez, the probability of obtaining a personal loan is 75%. So, what does this just tell us off the bat? So we're on like the second level of this, right? Or I guess the third level of this. And we can already see that if we want to sell more personal loans, okay, get people to obtain personal loans such that we can make money off of interest, that sort of thing. So sell more personal loans. It makes sense for us to market to people with an income level of greater than 99,000 and who have advanced or graduate degrees, so advanced degrees. Okay? And yeah, so you can see that these groups are drastically different, right? So maybe not market to the people that have over 99,000 and only an undergrad degree. Maybe just market to the ones over 99,000 and have the advanced degree. And then furthermore, this process continues. Okay, and we see the undergrad. It decides to split them based on family size, and it shows that of undergraduate degree people who make over 99,000 who have undergraduate degrees, if they have a family of less than 3, they're not at all likely to obtain a loan, as their probability of yes is less than 1%. But if they have a family of greater than 3, they are very likely to obtain a personal loan. Interesting. And it's up to you to kind of figure out why that might be. If it's a family of less than 3, presumably it's it's 2 spouses, right? And with that, potentially dual income, and the money is flowing, right? Maybe they don't have to have a loan, a personal loan, that is. I mean, I obviously have a mortgage or a car payment or something like that. But then we get into family of greater than or equal to 3, meaning they have kids. And now the likelihood of obtaining a loan goes drastically up. I mean, unbelievably drastically up. It's the difference is, 70+%. So that's interesting to note. And then lastly, we can just look over at the other one. Actually, I won't even cover that. I'll let you guys look at this other income less than 118 and greater than 118. So just just further shows something very interesting over there. Okay, so then we look down at this statement here at the bottom. If income greater than or equal to 99 and education equal undergrad and family greater than or equal to 3, then probability of class equal to yes, meaning yes, they obtain a personal loan, is 0.7847. Classify as accept the loan. So that is like the uber statistical jargon to say this number right here, this 0.7847. So if income greater than or equal to 99, that's the first part, and education equal undergrad, this second part here, and family of greater than or equal to 3, then the probability of the class being yes or the personal loan being accepted is 0.7847 or 78-ish%. Okay, so that's the general way to read these things. It's not too complicated, and all that split work gets done for you, so it's really, really nice because you just kind of set it and forget it. All right. Oh, and we got some graphics here that's going to show you how to move through it. Cool. Excuse me. So, as we just saw, a decision tree is the tree structure of rules, if-then rules, logical branching of cases. The branches are different possible values. The nodes are like the prior group that it was then subdivided from, and the root node was just like the all data. And then the terminal node is the final outcome node. All right. The example of a decision tree node, I feel like we've gotten into this, but the total number of customers in this node is the count, which makes sense. That's just us adding up our yeses and our nos. The percentage of customers in this node that did not accept the loan is going to be our probability, or that did accept the loan is going to be our probability. And the graphical presentation of the outcome variable personal loan between yes and no. Oh yeah, I didn't talk about that, and that would be smart. So it's talking about this red bar and this blue bar here, and that's just going to be the visual representation of the probability right here. Okay. Decision tree creation. So it's a hierarchical collection of rules. And I'll let you guys read through this. I think the main thing to take away is that it's choosing the splits optimally. Okay. And then you'll see when we go through this, but it's going to actually stop splitting when the variation explained by the model starts to wane. Okay. You guys remember the concept of R squared that we've seen in a couple of the distributions. So R squared is it's our correlation squared, so we call it our R squared, and it's also called the coefficient of determination. Okay, but the R squared represents the amount of variation that is explained by the model. Okay, so the variation in the outcomes that are explained by the model. So what our decision tree, excuse me, still getting over everything that I've had. Yeah, the virus has stuck around in our house. It's been like 3 weeks. It's killing me. But anyways, the R squared represents the variation that's explained by the model. Okay, and so our model, this decision tree, knows when to stop splitting when that R square starts to turn back around. So basically, what ends up happening is the decision tree is going to run until the R squared maxes out at a number of splits, and then it's going to stop running based upon that. So if it ran any further, the model would actually start to explain less variation in the outcomes. Okay, and this is all of the validation set that we used. So basically, we're looking to maximize the amount of explanation. And again, this thing does it for you. It's fantastic. Okay, so let's move on. Classificazione trees. No, I should edit that out. Anyways, all right. So yeah, let's get into it. So now this is going to be similar to us working through how we would like a class exercise sheet. Okay. All right. So revisit the universal bank data. So if you haven't already, go ahead and pause the video and download that universal bank data again, or access it and load it into Jump. As I've talked before, the bank has a database of liability customers, blah, 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 blah. You can go ahead and read through the same thing that we did in the last video. So you remember kind of what the setting was, what the business setting was. And then this is going to be us with a rule-based system to classify each applicant as a loan acceptor versus a non-acceptor. Okay, so I'm not going to go through all of these steps, especially the ones that were covered in the last video. So data mining step 1 of us like analyzing the data, or like just obtaining the data, yeah, you guys have done that. I don't need to show you how to download the data off of Brightspace. Fair enough, right? Or read through the problem. We've done that, or you guys did that already in the last one. And then in step 2, obtaining the data, which is literally in our case, downloading off of Brightspace. Step 3, pre-processing of data. I guess I can remind you of the pre-processing of data. Okay, so let's look at that. So the pre-processing of data is just what the normal steps that we take when we start the lab off, outside of downloading it and whatnot. What we do is we make sure that the variables are set correctly. So what would we do here? We would have to look at our variables here, and we want to make sure that they are adequately categorized. So you probably already have this done on yours if you're using the same data set that you used last time. But if you didn't, then you'll have to do this again. So we want to categorize these in the correct way. into nominal and continuous. So I'm just kind of assuming that you know what to do here and you know why to do it, because we have covered it. But what I'm doing is just walking through, changing these from continuous to nominal, because that is in fact what they are. The personal loan securities account, these are just yes and no's, like on-offs, essentially, like, is this person this type of customer? And so it should be noted as a categorical variable, which we put as nominal. Okay. So we've done that. So what is the next thing that we do? The next thing that we always do is we run a distribution. So this is, again, just pre-processing stuff. So if you're looking at your PowerPoint, we're on like slide, I think, 11. And we are on data mining step 3 of pre-processing. And we would just go to distribution, and we would just run all of it, essentially all of it, under the pre-processing. And now you probably remember doing this. So it's basically just us tossing all of the relevant variables into the Y and hitting OK. And there it is. And then I always go and hit stack. Okay, which then puts these into a decent format kind of to view. And then we just march down here and we make sure there's nothing that like seems off, or that we're not missing any data. And I mean, if you did this already, I think this data is pretty clean. So let's see here. Yeah, there's nothing, I mean, there's clearly nothing out of the ordinary on age. That looks like a very reasonable distribution. There's no real outliers or anything like that. Professional experience, very similar, kind of bell-shaped. Income, kind of skewed to the right. This is, I think, what we would expect. You know, a lot of people sort of in the middle class, and you obviously can't go below 0 as an income. And so then people with higher incomes kind of trailing off. That's pretty indicative of the real world. Family size here. That's kind of interesting. I wonder if the cutoff then is 5, and so maybe the 5 stands for 5 or more. And credit CC average, which I believe was average spending on credit cards per month, and then we see that that sort of trails off to the right with no real legitimate outliers. I think that's fair. These higher end ones might even be the higher income people. We don't know. We can check if we need to. Education seems okay, and that mortgage we saw last time, and that was, it looks funny at first until you kind of realize what's going on. Is we've got a bunch of these 0 mortgages, which just means it's people who have paid off their house. So it actually is like adequately skewed to the right, in that there's very few that have still high values on their mortgages, and it kind of gradually gets to a point where it's approaching 0, and then I think once people get close to it, they work to pay it off. Okay. Yeah. So this is our pre-processing stage. This is us just looking at the data, understanding it, making sure there's no missing data, cleaning the data if we need to. In this case, we don't need to. So then what we would always do here is, go and save the script and save it to our data table and call it, distribution, or sometimes you can call it whatever the number is that you're working on your assignment. Okay. So that is that. So let's move back over here and get to the next thing in the process. Running trees in Jump. Okay. So yeah, I've done the lab. I'm toying around with. I'm just not gonna run through the lab kind of step by step in the way that I did. So you are gonna have to rely on a little bit of prior knowledge when doing the lab. So I'm just gonna show you how to do the decision trees now in Jump. Okay, so it's just a new thing. I kind of assume that like you remember how to do the stuff from last week, and you remember how to do some of the stuff from previously in the semester. Okay, so data mining step for 4 for decision trees. Jump will partition the data for us. We just need to enter the portion that we want in our validation. Okay. Interesting. So I didn't do it that way. You can just run your validation like that. It looks like without running a validation column, or you can actually just have a validation column like we normally do. So I guess I'll invite you to try it both ways. If you would like to try it this way, where you run in and then you just specify a validation number, you're welcome to do that. I'm going to do it the normal way that we've kind of been accustomed to, okay? And I'll show you right now based on that. Okay, so if we want to run a decision tree on this, we would go to Analyze, Predictive Modeling, Partition. Okay, we get this, and see right down here is where it says, hey, you can put a validation portion in. So we're not going to do it this way. What I want to do is I want us to put a validation column in, like we would have kind of normally done for any other scenario. So in order to put a validation column in, we go to Analyze, Predictive Modeling, Make Validation Column. Okay, and we'll do our 60-40 split like it's asking for. And then formula random. Okay, and that creates a validation column for us as we are used to. All right, it should put it down. It should put it at the end of the data. If it doesn't put it at the end of the data, so what? Who cares? All right, so now we're going to get into step 4, data mining. Step 4, predictive modeling. Uh-oh, let me make sure that you can see that. Analyze, predictive modeling, partition. Boom. Okay. And so what we're going to do is we need to have our decision variable, so the thing that we're trying to predict the probability of, be our y variable. So the thing that we're trying to predict the probability of is whether or not they obtained a personal loan. So in the same way that we had done it before. So personal loan is going to go up in the y, and then everything else that's relevant, I guess I should say, goes in the x. And then our validation goes in the validation. Okay? Notice that in options here it says decision tree, so you don't change that. So that is that. So we hit OK. And it pulls up this, and that looks like nonsense, right? I mean, that looks cray. That's fine. One thing that we need to go through, which isn't shown in our slides, and it's a little bit frustrating because I think Jump just automatically does this, and it's very hard to understand, is this sort of thing. It has a count, and then it has a g squared. This g squared is, what is it? G squared is the likelihood ratio chi-squared statistic. Okay, but that doesn't mean anything to you. You want probabilities, right? So in order to do probabilities, we have to go up to our red flag and click Display Options. Oh gosh, come on, stay in window. Here we go. Red flag, Display Options, and then Show Split Prob. We put that in there, and then now the probabilities are in there. And then now, furthermore, I just don't even want to see that g squared stuff. Display Options, Show Split Stats, and we get rid of that. Boom. Okay, and that's done. So now it looks like something that we liked, and let's go ahead and add in the count as well that we saw in the other graphic. So now we have the count as well. So this is this. In the lab, it's going to ask you to color the points. In order to color the points, you just hit Color Points, and now it colors the points into accept and not accept. So we have a 1 over here for accepted a personal loan. So this would be the probability of accepting a personal loan of the whole data set. And like this blue sliver is. And we see that that probability is like 9-ish% or almost 10%. So that is representative by a bunch of these dots here, these blue dots. And then the red is the probability of not accepting a personal loan. Okay, assuming we've set everything up right, meaning we put all the right data in, put all the right variables in, that whole thing is good. And we put our validation column in. The validation column is a must. All we have to do is hit go. And then it, for whatever reason, I'm using a big monitor, so it wants to do that whole thing. Okay. So we've hit go, and it runs this whole thing. All right. Okay. So I'm going to try to make this easy for you to understand. So this thing looks crazy, right? This is not easy to understand. Let's try to do this. Sorry that this is the way that it is. All right. So this is going to be what happens. I mean, maybe this isn't a bad thing. Your video should look similar to this, right? You might have some variation in this just because your validation column might have been made a little bit differently than mine, just due to randomness. But you should see something that looks like this. You should see something that you are able to read in the same way that we read this before. Okay, so in order to determine who is getting a loan and who's not, the first thing that it wants to do is divide these people into income greater than 95 and income less than 95. Okay, so yeah, mine is working a little bit differently than what we saw before. What else here? Let's go down. So yeah, that's how you run that. Now this thing, split history, is interesting to note. This is showing you the number of splits in the data. Okay, so it also says it up here. So it says it in this little table here. It gives us the R² value of the training set and the R² value of the validation set. And it tells you the number of splits. This is the optimal number of splits. So this is how many times it went split, 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 split. So it should be 1, 2, 3, 4, 5, 6, 7, yeah. So there's 9 total. Okay, it's not going to be 9 rows. It's going to be 9 actual node splits. Okay. All right. And so then when it decides on 9, it's because looking at this graph, the red line is representative of the validation R² value. Okay, so if notice their R² are very similar, these graphs are very similar. As we follow this, the R² value for the validation column for the red peaks right there. Okay, peaks at 9 splits. Then it goes down from 8, and then it goes down at 10, down further at 11, and sort of kind of rattles off. But what the computer is noticing, so it actually ran it up to like 18 or 19 splits, but it's noticing that it hits its peak of explanation of the data at 9 splits. So that's where it decides it is optimal at. Okay? And that's why it stopped where it stopped. Okay. Now the next thing to look at would be the thing called the leaf report, which is a really nice tool that I wish my, here we go, the leaf, here we go. Sorry guys, I'm trying to make this as organized as possible and the menus are wanting to go off to the right. So we want to look at the leaf report, which is just in our red triangle here, and we scroll down to leaf report, and it pulls this up. And so what it does is it automatically is telling you these probability values, the probability values associated with the rules that it's coming up with. So basically all of these leaves on the branches Okay, every single grouping. Oh, that's really confusing. That's my son. Okay, every single one of these groupings, it is going to give you a rule and probabilities for. So this is basically just the tabular table, version of what we see up here. So we have income greater than 95 and education 2 or 3 and income 118. Really, really, really likely that they are going to get a personal loan. Okay, and we can go up here in the table and find that. That would be income greater than 95, education 2 or 3, 2 or 3 being advanced degree or grad degree, and income greater than 118, 0.9958 of accepting a personal loan, and we see that that's the first thing on our leaf report. So you can go ahead and play around with this. Yours are going to match the numbers that you have. Like I said, they might be slightly different than mine. And then what else should we do? We've talked about R squared. We talked about a misclassification rate last time. Excuse me, in last video. The next thing I want to get to, also because I don't want the video to run long, is the confusion matrix, which is actually in a different spot than it normally is in. And the confusion matrix, if I can remember, is where? It is show fit details. It is. It is in show fit details. And then that's going to pull up the confusion matrix. Cool, cool, cool. And yeah, that's that. That's your confusion matrix. So if you remember how to do the misclassification rate, those sorts of things, that's all from the confusion matrix, or the accuracy rate or anything like that. Okay? Well, I know that this one probably feels a little bit different than last time, but like I said, I wanted to try it out. If the quality didn't go down that much, then great. If it did, give me that feedback. If you would like more of like the worksheet style next time, I have a feeling that's what you guys are going to say, but we'll see. But I think you get everything that you need here. So yeah, let's have a good lab on Wednesday, and I look forward to seeing you all there. Yeah. All right. Thanks so much, guys.